And so it's my pleasure to introduce Cameron Isle. He comes to us from beautiful Woodstock, Georgia. Is that Woodstock High School?
I went to a bunch, but yes, that was one of them. That was one of them.
Give me the details. Which one did you graduate from?
Mountain Education Charter School.
Oh my
it was a night school.
Oh my goodness. Okay. All right. Fair enough. So tell me a little bit more about training wild Mustangs.
Yeah, so I've been working in veterinary medicine for a long time, but I actually got my start by training wild Mustangs or wild horses that were captured by the Bureau of Land Management with mostly alongside a well-known trainer named Betsy Moles. I think she got married though and her last name changed, but
where were they from?
Did that for a long time.
Where are the horses coming from?
Most of them are usually rounded up in Nevada.
Nevada.
Yeah,
okay.
Nevada's like the main.
You know, there's the whole wild horse population on the Barrier Islands of North Carolina.
Oh yeah.
Out west. Oh, interesting. So there's training going on here of the animals that have been since displaced. Oh, okay. So, but you know, obviously he's very much involved in veterinary medicine, pre-veterinary medicine, and this is an opportunity, as a lot of students are doing this semester, to explore in depth the research associated with the treatment plan that is, in this particular case, is experimental. And so the official title is a nucleoside analog, GS, some number, is an efficient and safe treatment. It rolls off his tongue. It does not roll off my tongue. It's a safe treatment option for cats with FIP. So we'll talk about FIP and introduce to a really interesting clinical trial that's going on with respect to this particular drug. So Cameron, the floor is yours.
Perfect. Hello everyone, like Dr. Bobby said, my name is Cameron Isle, and today I'm going to be talking about how the nucleoside analog GS-441524 is an effective and safe treatment option for cats with FIP. As Dr. Bobby mentioned, I'm currently a veterinary technician and I've worked in veterinary medicine for about 7 years now. During that time, I've noted a significant gap in the standard of care when it comes to cats, both within veterinary medicine and just by the general public. People often either love or absolutely hate cats, leaving them with negative stereotypes such as them just being naturally mean or unfriendly or even described as evil for some people. These negative stereotypes often lead to less compassionate handling and therefore the underdiagnosis and mismanagement of common feline diseases. For instance, if a dog growls or bites someone because of fear and anxiety, a lot of times people are pretty quick to understand that behavior is caused by the anxiety and the circumstances. But if a cat hisses and bites someone due to anxiety, a lot of times the cat itself or the entire species even is blamed rather than the fear. This unfair treatment can also be applied to research endeavors. For instance, the feline genome is significantly less laid out and just researched and mapped in general in comparison to even just the canine genome. This is really difficult, especially when trying to track hereditary conditions. Additionally, this lack of research leads to less feline-specific medications. So in veterinary medicine, a lot of treatments for cats rely on the off-label drug use for medications formulated only for dogs. So now that we have a bit of a background on why I wanted to give this talk on this topic, I just wanted to orient y'all a little bit more to what I plan on covering today. I'm going to start by describing what FIP is, then I'm going to go into why we should even care about this, next what we knew versus what we were missing before my experiment of focus today, which will lead me into our experiment of focus, which is Peterson et al. And finally, I'll tie it all together with the bigger picture. So just starting out, what is FIP? In order to understand what FIP is, we must first understand what FCoV or feline coronavirus is. FCoV is typically transmitted through the fecal to oral route, as the virus is typically housed along the GI tract and shed through feces. It has very similar pathogenicity to SARS-CoV-2, the causative agent to COVID-19, and similar to SARS-CoV-2, it has very high prevalence with 80 to 90% of cats living in multi-cat households testing seropositive for the virus. So most cats naturally eliminate FCoV after infection, but if they don't or they're unable to, oftentimes the mutations occur that cause a cellular tropism switch. So instead of the virus attacking cells along the GI tract and staying defined to that one body system, the virus instead begins attacking immune cells such as macrophages, allowing the disease to be easily spread throughout the entire body instead of just staying put in one spot. 5 to 12% of cats infected with FCoV develop these mutations in their spike protein genes, leading them then to develop FIP. So even though FIP itself is not as prevalent as FCoV, it is not a rare occurrence for these mutations to occur and for that transition to happen. So now that we know what causes FIP, what exactly does that look like? FIP comes in two main forms. There's in a wet or an effusive form and a dry or non-effusive form. With the wet form, you usually expect to see what the name entails, a lot of wetness and just fluid buildup throughout the body. So some common symptoms would be pleural effusion, which is just fluid buildup between the chest wall and lungs, pericardial effusion, which is fluid buildup around the heart, ascites, which is just fluid buildup in the abdomen, while in contrast, the dry form, you wouldn't expect to see that fluid buildup. Instead, the main hallmark is going to be internal lesions and growths on internal organs and just throughout, especially the GI tract. In neurological cases, you'll see vestibular signs, so cats leaning to one side, loss of coordination, muscle weakness, things of that nature. And in ocular cases, you'll have things like uveitis, which is just inflammation of the middle layer of the eye. On this graphic here, we can see how FIP can affect all the major body systems in a cat, though. Everything from ophthalmologic, respiratory, dermatological, cardiovascular, reproductive, and gastroenterological systems can easily have symptoms from FIP infection. So now that we know kind of all these symptoms that can be caused, what exactly does that look like manifestations-wise? On this video here, okay, well, on this video, if it had played, you would see that the cat attempts to climb the cat tree, but it's really wobbly approaching it. And even though it does attempt to cling on and pull itself up, it just no longer has that coordination and that muscle strength in order to actually get its body up. So it kind of ends up just toppling over. It's kind of sad. On this next slide here, though, we can see some ocular manifestations of FIP. So the uveitis, which is again just that inflammation of the middle layer of the eye, can look like just a cloudiness around the entire eye or even just in small segments shown there. And just as a quick content warning, I know Dr. Bobby kind of previewed it, but the next slide does have necropsy results. So it is going to show the open abdomen of a cat and organs. So if you don't like that, just look away for a moment. Here you can see the just basic overview hallmark signs of just wet versus dry FIP. On panel C here, we can see with wet FIP, there's just fluid everywhere throughout this cat's abdomen, along with even some nodes along the GI tract. Whereas on panel D, this comes from a cat with dry FIP. These are a pair of feline kidneys, and you can see there's just significant lesions and growths all throughout the organs, and you would expect to see that on all major organs throughout the body. So now that we know what causes FIP and what it looks like symptomatically, but why should we even care about this disease if it only affects cats? First of all, FIP is not some uncommon rare disease that only affects a few cats here or there. In fact, one of every 200 cats that present to veterinary teaching hospitals in the United States, such as UGA, represents a cat with FIP. Additionally, FIP is a leading cause of death for young cats and kittens. 1 out of 100 of those same cats that present to American veterinary teaching hospitals die due to FIP, with the prevalence 5 to 10 times greater in young cats and kittens that come from shelters and catteries and just general multi-cat places. That said, let's say hypothetically you are one of those people that just hates cats. Why should you in particular care about this? In short, the answer lies in public health. FCoV and SARS-CoV-2 are both coronaviruses, and because of that, they are pretty closely related in respect to their genome, their receptor binding domain of spike proteins, and receptor usage. Because of that, finding a treatment for FIP could later create a foil for other experiments to find treatments for other RNA viruses later on. Additionally, we already know within the scientific community that there's a big gap in research when it comes to population genetics and understanding how that works. And we also know at least 50% of FIP is caused by an unknown hereditary component. Because of this, by studying FIP and understanding and studying the potential hereditary components, we will not only gain more insights within feline medicine and feline research, but also just population genetics as a whole. So now we have covered some of the basic background information regarding FIP, FCoV, and why it matters outside of veterinary medicine. but we can go ahead and dive a little bit deeper into what we actually knew versus what was missing. First of all, before our experiment of focus today, we already knew that GS-441524 resulted in premature termination of viral RNA synthesis. So we already kind of had an idea of how it worked in the body due to previous studies in other animals. I'm just going to refer to it as GS from here on out. But GS targets the viral genome replication process by metabolizing itself into an active nucleoside triphosphate. That NTP can then compete with ATP for incorporation into the new synthesized RNA strand. And once it is incorporated, it terminates that synthesis early. And just so you kind of have a better idea of how this happens, I have just a regular ATP molecule shown on the top here with the metabolized NTP molecule shown at the bottom. As you can tell, just like the general structure is very similar, they really only differ by a few select functional groups here and there. So it's not very difficult for the body to use them interchangeably. Outside of that, we actually already also had one experiment showing that GS was effective in cats with experimentally effusive FIP. We found that the medication was non-toxic in cat cells up to concentrations of 100 micromolars, and synthesizing new medications for cats usually is a little bit of a problem because they tend to be more sensitive and have more issues with toxicity, so this was a really big deal. Additionally, their experiment showed rapid reversal of disease signs within 2+ weeks in 10 out of the 10 lab cats with that experimental FIP. And finally, there was complete inhibition of FIPV relocation in CRFK cells, which are just a continuously dividing line of cells derived from feline kidneys. So we have all this information. We know that GS showed to be effective in cats with experimental FIP, and we knew how it kind of worked within the body. So it made sense theoretically, but what did we do with that information? We started asking, so like I said, we knew that, but what about the cats with naturally occurring FIP? And what about cats with the dry forms? Since previously we only really knew information about cats with the effusive forms. This leads me into our experiment of focus today with Peterson et al. Peterson et al. In 2019 set out to answer some of these questions. He asked the research question of how efficient and safe is GS in treating naturally occurring FIP. He hypothesized that GS-441524 would be a safe and effective treatment option for naturally occurring FIP. And finally, he predicted, based off of previous studies, that cats treated with a dose of 2 to 4 milligrams per kilograms for a minimum of 12 weeks would reach clinical remission. So Peterson et al. Selected 31 different cats, all of which with a previous FIP diagnosis. That said, though they all did have that previous diagnosis, they did just want to confirm that it was accurate. So they confirmed the diagnosis by a few different methods. First, they ran reverse transcriptase PCR to check for viral transcripts in the RNA. They also did physical examinations, especially with specialists in neurology and ophthalmology, to confirm ocular and neurological cases. And finally, they did some ultrasounds to check for that free fluid throughout the body or lesions on internal organs. The selected participants were pretty diverse. That said, the majority of them were of mixed breeds with effusive FIP. 13 of the cats were purebreds, while 18 of them were domestic shorthairs or domestic longhairs. 26 of the cats had effusive or wet FIP, and only 5 of the cats had dry FIP. Additionally, all sexes were represented in this study, but the vast majority were neutered males, making up 16 of those cats. There was also 1 intact male, though, 7 spayed females, and 7 intact females. So now we know what the participants looked like and how they went about reconfirming those diagnoses, but what exactly did the experiment itself look like? Peterson et al. Conducted a clinical trial where he took those 31 cats and administered 2 to 4 milligrams per kilogram of the GS medication subcutaneously every 24 hours for a minimum of 12 weeks. During that entire time, they collected a variety of data to try to help them narrow down when they can say a cat fully reached clinical remission. The first one would just be vitals and behavioral symptoms. So this included like temperature, pulse, respiratory rate, and then even behavioral things like urination, defecation, appetite, water intake, lethargy, and even the appearance or disappearance of ocular, neurologic, or effusive symptoms. They also took ascites and cell samples from 8 of the cats and ran more of the reverse transcriptase PCRs looking for that FIPV RNA within their transcripts, and they took just general blood work every 1 to 3 days to see if the treatment caused any internal changes. On this figure here, we can see the levels of that FIPV7B RNA transcripts in the cats that they collected the samples from. Just to kind of orient you to the figure, on the top here, we have the sample ID, days of treatment, sample type, and copies of viral RNA per milliliter. On the side, we have the different cat IDs, and each cat's data is organized into a different colored box. Just as a whole, you can see that 6 of the samples came from the ascites, and 2 of the samples came directly from cells. The vast majority, aka 7 out of the 8 cats, showed a decrease in viral RNA by the end of treatment data collection. The only cat that was a little bit of an outlier is shown here in the orange box. You can see he initially did have a decrease in his viral RNA transcripts, but on the last day of collection at day 9, that did spike back up. 50% of the cats also were already undetectable by the end of this data collection, shown here, 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 and here. But I do believe if they collected data for a little bit longer, all cats would have eventually shown up as undetectable. On this next graph here, we look at the temperature of the cats during the initial treatment with GS-441524. On the y-axis, we have temperature in either Fahrenheit or Celsius, depending on the side you're looking at, and we have hours after starting treatment on the x-axis. The normal temperature range for cats is usually about 100.5 to 102.5. As you can see, all cats started with a temperature around 103.3, which is a clinical fever. That said, after just 12 hours of treatment, that temperature dropped to 102.5 back into normal range. For the rest of data collection, that temperature remained within those normal ranges, obviously indicating that the drugs seem to be working. On this slide here, we're looking at 2 different blood work values. On panel A, we're looking at the white blood cells per microliter on the y-axis and week of treatment on the x-axis. Cats did present with elevated white blood cells just below 17,000, but once again, just after 1 to 2 weeks of treatment, that number dropped once again back into that normal range. On panel B, we see lymphocytes per microliter on the y-axis and week of treatment on the x-axis. Lymphanemia is actually which is just very low lymphocytes, is a very common sign and symptom of RNA viruses. So, as expected, all cats did present with very low lymphocytes. That said, just after 1 week of treatment, again, that number spiked back up to the normal levels and remained there for the rest of data collection. So noticing some good trends here. This next slide here, we're looking at the albumin to globulin ratio, which is a low A to G ratio is actually a hallmark sign of FIP. So again, as expected, we see the cats presenting with around 0.4 to 0.5 AG ratio at the very beginning, but by the end of treatment, that number goes up a little bit past 0.8. There's also a R-squared value of 0.7383, indicating a high level of correlation moving upwards. This is our final blood work slide, I promise, but this one we're looking at the packed cell volume, or just the PCV. PCV shows the amount of red blood cells present in a specific sample. It's typically displayed as a percentage up here. Then on the x-axis, we have the week of treatment. Cats did present with decreased PCV values just above 30. The same thing as with the AG to G ratio. By the end of treatment, that number was just around 40, which is within normal range. Once again, there was also an R-squared value of 0.7478, indicating once again another high level of correlation moving upwards. Okay, so this is probably the most summative and clear figure from this entire experiment, though it is a little bit busy to look at first, so let me just orient you all a little bit. On the top here, we have the weeks of treatment, and all along the side, we have the different cat IDs. That said, the key is going to be the most important thing. So a solid line indicates a 2 milligram per kilogram dose. A broken line indicates a 4 milligram per kilogram dose. An asterisk indicates a point of relapse. Remission dates are indicated in parentheses. And if a cat did pass away, that is indicated by a cross and the cause of death next to it. Just to point out kind of some major trends from this graph, most cats did reach clinical remission within the 12 to 16 week range. That said, though, again, that was the majority of the cats, there were still a few that experienced some relapses along the way, indicated again by that asterisk. That said, all those cats that did have those relapses all did reach the clinical remission on the higher dose. So they did need to adjust the initial protocol a little bit, but in the end, it was the same results. It is also important to note out that 5 of the cats did pass away within the first 1 to 3 days just due to disease severity. So it didn't have anything to do with the treatment. They sadly just got put into the trial a little bit too late, so it was more humane to euthanize them at that point. There was also 1 cat that did pass later on after it reached remission due to a completely unrelated cardiac disease. But they did a necropsy, and again, they confirmed that there was no viral RNA found within the cat's body. Then just to summarize those many figures, the remaining 26 cats did extremely well in the study. 25 out of the 26 cats achieved sustained remission of FIP, besides the one that did pass from the unrelated heart issue. And just as a whole, their temperature decreased, their blood work improved, symptoms such as the uveitis, the vestibular signs, the effusion, that all resolved, and viral RNA decreased in the majority of cats. All of these signs together do point to the cats reaching clinical remission. So then just to tie everything together into the bigger picture here. First of all, first and foremost, GS-441524 is safe and effective. This is a huge deal, especially in veterinary medicine in particular, because like I said, FIP was previously 100% fatal. It was found out in 1963, and up until literally this year, basically, if your cat had FIP, it was going to have to be euthanized or die naturally. So because of Peterson's research, now diagnosis does not equal an automatic death sentence. Now cats do have that additional chance. Of course, there's still some like socioeconomic factors and things, as this is the only medication, so there's some more factors in there, but in theory, they have a chance. Additionally, his research provides a foil for future antiviral medications and antiviral just studies in general, whether it's looking at RNA viruses or population genetics. And Peterson's research also increased the quality of life for the cats that are obviously no longer dying, and the owners that are no longer having to watch their cats die. In fact, his research, along with several other studies since 2019, actually led to a really huge breakthrough in veterinary medicine just earlier this year. In June of this year, the FDA actually approved GS-441524 for legal compounding and therefore the mass availability of within the US through Stokes Pharmacy. So Stokes Pharmacy is the only people allowed to make this medication and distribute it, but still, it's such a huge deal because before people were still trying to buy the medication after Peterson's paper came out, just from like the black market and things like that, which led to a lot of unregulated medications circulating around with very different concentrations and therefore very differing effectivity. And finally, just kind of as my final take-home message, so if you don't remember anything else, the most important facts is that clinical remission was noted in 25 out of the 26 cats. There was only 1 cat that technically wasn't included in this because he died from unrelated cardiac disease. GS-441524 was found to be safe and efficient for treating naturally occurring FIP, meaning Peterson et al.'s hypothesis was completely supported. And additionally, like I said earlier, this research provides the basis for further studies on RNA viruses, population genetics, antivirals in general, other coronaviruses, and the eventual FDA approval of the medication just earlier this year. I also didn't include it on here, but just kind of as a little fun fact, Peterson is actually his whole thing is FIP. He's been writing about FIP since like 1980s. something like that. And honestly, like the approval of the medication was almost all like his research, which I found very interesting. But that is all for me.
Thank you very much, Aaron. We got a couple minutes. How about some questions?
Yes.
First of all, I'd like to say that thank you for talking about this because it's not talked about enough, and I am so glad to hear that there is finally something that can be done. How much does the medication cost right now, do you know?
I actually looked this up last night because I figured someone would probably ask. So the normal, now through Stokes at least, they usually ask people, if I remember correctly, the normal like treatment length is 84 days, and they sell, you can either get like the tablets or the oral suspension, but usually the biggest size you can get is 40 days at a time. And that 40 count bottle is, if I remember correctly, I think like $550 or something. So I think I calculated it for a 10-pound cat, and just very roughly off the top of my head, I think it amounted to around $1,200, $1,500, which is still an insane amount of money. But when, I mean, just a common like emergency vet bill often is like triple that. So the people that are interested in getting this medication, I don't think that's a huge factor there.
I'd buy it still.
Yeah. Yeah.
Have you had to do any cats with FIP at your clinic?
Yes, actually. Quite a few. Sadly, not all of them are able to access this medication, which is, again, like I said, socioeconomic factors. Hopefully, as more research continues to go out and it becomes a little bit more accessible and it's not just one pharmacy, that price will go down. But we have had some people successfully take the treatment and it's worked, it's gone great, and we have had some people elect to euthanize instead. Any other questions?
So in the data, they seem to be tracking white blood cells. Why?
I mean, usually, just like with humans, your white blood cells are going to increase if you're having like an immune response. So when they start to go down, that kind of is an indicator that your body's chilling out a little bit and maybe things are starting to improve. Anything else?
Well, I apologize.
Okay.
We got kind of a little start, so
That's
I
okay.
cut some off, particularly how much people tend to like cats. Or hate cats, or like cats. So either way, let's thank